Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Tutorial, Part 3. In this video we will discuss about NumPy advanced attributes and advanced NumPy methods. Let's get started. Alright, first we will import the NumPy library. So now we will discuss about NumPy advanced array attributes. NumPy is a powerful numerical computing library in Python that provides support for large multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. NumPy arrays have several attributes that provide information about the array. Let's explore some of the key attributes. Alright, first we will discuss about strides. The strides attribute returns the number of bytes to step in each dimension when traversing the array. Now you can see here we got 12 and 4. Now we will know about why we got 12 and 4. Let's see here, the first value, 12, represents the number of bytes to move from one row to the next within the same column. This is calculated by multiplying the size of the data type of the array by the number of elements in a row. In this case, the data type is likely integer 64, and there are 3 elements in each row. So, 8 bytes multiplied by 3 elements equals 24 bytes per row. However, the strides value is 12, which suggests that the array is stored in a C-style contiguous memory layout, where each row is stored in a contiguous block of memory. The second value, 4, represents the number of bytes to move from one element to the next within the same row. This is calculated by multiplying the size of the data type by the number of elements in a column. In this case, it is 8 bytes * 1 element equals 8 bytes per column. However, the strides value is 4, which suggests that the array is stored in a C-style contiguous memory layout, where each element in a row is stored in a contiguous block of memory. In summary, the 12 and 4 strides indicate that the array is stored in a C-style contiguous memory layout, with each row stored in a contiguous block of memory, and each element within a row stored in a contiguous block of memory. Now we will discuss about flags. The flags attribute provides information about the memory layout of the array. Now you can see here we got different type of flags. Let's break down each of these flags. Let's see here, C contiguous, true, this means that the array is stored in memory in a C-style contiguous order. In C order, the last axis changes fastest, so the elements within a row are stored in contiguous memory. F contiguous false, this means that the array is not stored in memory in a Fortran-style contiguous order. In Fortran order, the first axis changes fastest. Next, own data, true, this indicates that the array owns its own data. In other words, the array is not just a view or a slice of another array, it has its own data in memory. Next, writable, true, this indicates that the array is writable. You can modify the contents of the array. Next, aligned, true, this indicates that the memory block supporting the array is aligned. Next, write back if copy, false, this is related to copying behavior. If this is true, and the array is a copy of another array, modifications to the data will be written back to the original data, if possible. In this case, it's false, so modifications won't be written back. Now we will discuss about real and imaginary. For complex arrays, real and imag attributes return the real and imaginary parts. Now you can see here, 1 and 3 is real number. And 2 and 4 is imaginary number. Now we will discuss about some advanced methods. Alright, first we will know about reshape. The reshape method changes the shape of the array without changing its data. Let's see here, this is a one-dimensional array. This reshape method will convert it to a two-dimensional array. As you can see here we got two-dimensional array. Similarly, now we will convert two-dimensional array to one-dimensional array. Now you can see here, our two-dimensional array is converted to one-dimensional array. Now we will discuss about flatten and ravel. Both methods flatten the array into a one-dimensional array. Now you can see here we got exact same output from both methods. Now we will discuss about transpose. The transpose method permutes the dimensions of the array. Let's see the example. As you can see the output. Now we will discuss about dot. The dot method performs dot product of two arrays. Now see here the output. Let's break down each of these values. Now see here, element at 0, 0. This 1 multiply by this 5. Plus this 2 multiply by this 7. Equal to 5 plus 14 equal to 19, so that's why here we got 19. And the rest of the value we got in the following way. Now we will discuss one last thing. NumPy provides methods for various statistical operations on arrays. Alright, now you can see here we got sum, average, standard deviation, minimum, maximum, etc. So guys, these are just a few examples of the advanced attributes and methods in NumPy. The library offers a wide range of functionality for numerical computing and manipulation of arrays. So our today's video was up to this. Thanks for watching the video. See you in the next video. Please subscribe our channel and don't forget to like the video. Thank you.